Hello everyone, welcome to the stream. Today we will be continuing our work on the iCEBreaker bitsy. So as you might remember in the previous episodes, we were designing a new revision of the board, of the FPGA board. Today we will continue that work because I got the PCBs and I got the parts, so we can assemble prototypes and test them. I'm not sure we will come around to testing them today, but at least we can assemble a few of the units. So to explain what it is, so what we are working on here, this is the iCEBreaker. iCEBreaker is an iCE40 up5K FPGA development board and teaching board. You can find it on CrowdSupply, Mouser, and in the 1bit² store. It is meant for teaching people how to use FPGA as well as for your projects as a development board. It has all the GPIO brought out and has some features like this PMOD that is pre-sorted and whatnot. So yeah, that is the... And it is supported by open source FPGA development tools, so you don't need to rely on the vendor tools, which are, yeah, and they are known to be a little bit painful to use, and if you are lucky, they run on Windows. Actually, there is also a Linux version of it, but macOS, for example, is completely out. So if you want to use something a little bit easier, the open source toolchain works, and it can be used commercially because it's pretty advanced by now. And based on the iCEBreaker, there is a little bit of a history here. So you might know this wonderful device. This is a Teensy, which is an ARM Cortex M3 or M4, depending on which version you have, Arduino development board, which fits on a breadboard. And this was designed by Paul Stoffregen. And he sells these. This is, in my opinion, the best Arduino board that I know, because actually the software is pretty good and it's actually nice to develop for. It has a lot of nice libraries for audio editing and whatnot. So I can recommend these. And I know Paul, and at some point I needed a board that I can use to show off what the Blackmagic probe can do, and I needed a board that has an ARM Cortex on it and has a JTAG connector on it. So I made these. These are bitsys, or 1bitsys, and the 1bitsy is this board. We are currently out of stock of them, and I'm not sure when I will come around to making more of them, but these are mostly just demos to show you how to use Blackmagic Probe for debugging and development for ARM Cortex. And there's also, in similar form factor, the iCEBitsy from Adafruit, which is this. And so this is a form factor that became somewhat established, and the people like Luc Valente, who is Tiny FPGA on Twitter also, so you can find him. He designed these boards, which are pretty much exactly the footprint of the Teensy, and it's actually pinout compatible as far as I know, and it has an FPGA on it. It is an iCE40 LP chip that is on here, and you can do FPGA development on it. And based on that, I saw all this and I was making the iCEBreaker. I was like, well, it would be cool to have a breadboard friendly version of the iCEBreaker. So I made this one, which is the iCEBreaker bitsy, and it's a small form factor breadboard friendly version of it. It's not exactly, it is close to the Teensy footprint and pinout, but it's not exactly. And I think in the next revision we will try to get it closer to the Teensy pinout. I think that would be useful. I have some ideas about this. We will talk about this in the future. The problem with that was this requires an external bootloader. So the bootloader basically does USB and it flashes the chip, and this didn't work on the up5K because it's a little bit slower FPGA. But over the last year, since I made the first prototype, Sylvain Manau made the second revision of the board, and several people, including him, worked on the bootloader for the FOMU, which is a small USB pluggable version of it, which is this guy, and they sorted out the USB stack. And now it is time to actually make these boards and make new revisions. So based on some additional experiences that we had with the iCEBreaker and additional input from the community, we made the next revision, which is the 0.3 version. And this is what we will be assembling today. If you have more questions about the details, it's like there's 4 episodes of streams that are archived on YouTube. You're welcome to watch all of it. I explain much more in detail all the design decisions of the board. You can try to ask them here in chat. I'm not promising I will answer everything, but maybe the community will answer your questions if you have any. So yeah. So I have my magic box that I call. It has a lot of the different parts. We have soda paste, and we have squeegees. Let me see that I can get you in here, like this. So this is these are my soda paste squeegees. I have a spatula that I can get some soda paste, and this is my setup how I stencil soda paste onto the boards. I can show you a little bit closer here. Already finger smudges on there, but yeah, this is a Osh stencil. I end up just buying them from Osh Stencils because I had always very good results with them. They're obviously more expensive, a little bit more expensive than just getting a cheapo stencil from China. But I got annoyed with variability and issues with the Chinese stencils and the metal being like all valleys and like all bent. Or yeah. It is possible you can save money and get them from China, like a stencil, but I like the Osh stencils. They are not super expensive, and the quality is top notch. The material is straight, it's flat, and yeah, and it's a business I think that is worth supporting. So I like buying stencils from them. You could get also a Kapton stencil, which are cheaper, but I don't really buy them anymore. Because the metal ones are so much less problematic. The Kapton ones work only for like 10 boards and then they wear out. And also like the accuracy of them is not as great and they don't seal as well and they are warbly. And so yeah, the metal ones are the way to go in my opinion. Yeah, it is okay. It is, yeah, you can use them. I'm just lazy and spoiled, and I just prefer these. I'm not saying you should buy these 100%, but this is what I prefer. It saves me time and headache, and the quality of the stenciling is better afterwards. No, so yeah, in theory yes, but it's like you actually don't see it as well because it's transparent. You don't see when you have the right alignment. With these you get somewhat of a moire effect, and you see when they darken and lighten up. So you, even with naked eye without any magnification, you can see that they are aligned properly. So this is actually pretty cool. With the non-transparent ones. The Kapton ones are, I find, harder to align actually than the metal ones. Also, there's this wonderful tool that horologists are famous for, and I just use these, and then I can check that it is aligned correctly, and you're done. So yeah, I think even for alignment, this is actually a better solution. Yeah. Alrighty, so let's open this solder paste and zoom out a little bit again. So that's solder paste. And I am using leaded solder today for prototypes because rework is easier. And what is it? This is the NC676 from FCT assembly. So it's a 6337. Yeah, this is, and I think this is type, this is the problem. It's like it's already worn out. I think it is type 4. So it is a finer ball size than the standard size. So I like the finer stuff because I can get better feature definition with the finer grid size. I have a preference for a squeegee. I got these ages ago. So this is actually a thicker stencil material. This is I ordered a few stencils from how are they called? Stencils Unlimited. That's the company. Stencils Unlimited. I ordered, they have a tier where you can get a small stencil plus a matching squeegee out of a thicker material. They are also laser cut. You don't see it here under the tape, but it's like, it actually has like a tongue here, and they work fine by hand, but I added this wooden thing that I just glued on with blue tape, and this way I get good leverage and I can get really nice action here. Also, because I have two of them, I can work the solder paste into a nice bead. You will see it in a second. So I have two of them, and this is really great solution. Don Carmelo, thank you very much for the Twitch Prime subscription. I really appreciate it. Thank you so much. Welcome to the stream. Yeah. Old PCB for a squeegee? Yeah, that might work. Yeah, the important thing is you don't want to use a razor blade because it's too sharp. You want something with a little bit of a softer surface. You want something bendable so that you can apply even pressure and it can comply a little bit with the holes and whatnot. I try to use the dedicated squeegees that are meant for solder paste. I didn't like them. They are usually huge. You can't get them, like, it's hard to get them in really small sizes, and the metal on them is usually, or the plastic didn't work for me at all because it was just getting too deep into the holes, the plastic ones. The metal ones were too stiff. And so these, actually, I love those the best. It's like I'm doing all production just with using these stencils, these squeegees. So yeah. Let's see the magic now. Yeah, there you go. So important thing, let's do some stirring. Let's even out a little bit the mixy. All right, now I should probably zoom out a little bit more even. There we go. So I have never managed to use up a full container before the solder paste went bad. So I'm keeping the solder paste in a fridge in a Tupperware container, and I try to not dry it out. But it essentially, after 1 year, after about a year, the solder paste goes bad. I'm not cloning stuff. It's not a clone. It's an iCEBreaker FPGA development board. It's a iCEBreaker bitsy that we are working on here. Why would I make a clone? Why can't I just develop my own stuff? Why is that your first thought, that I might be making a clone of something? But yeah, so this is the iCEBreaker bitsy, which is an FPGA development board that is meant to run MicroPython, for example. So this is something we will be, is already mostly ported, as far as I understand, or fully ported actually. Sylvain did a great job on this, and several others. And having Rust running on this, and C with the RISC-V cores, or just bare metal FPGA design. So yeah. So we will be, because I don't like assembling just one board at a time, so I will be, because it's a waste of time otherwise. So we will be assembling 3 of them. And you might, and that's it. That was one done. That was that easy. I'm talking, so I'm a little bit slower than usual. The easiest one is actually to use tweezers to lift it. Well, that's done. So let's see, how does this look? Yeah, it's not perfectly aligned, but this is totally within tolerance. Is that visible? Let's see. Yeah, so this is how it looks. My solder paste is a little bit more runny than the one that I know Greg DeVille is using. So my definition is not as tight as his photos. Let's see. Is that visible? No, actually this is not bad. It's very dark though. Sorry about that. That's the brightest I can make it. This looks actually sharper under the microscope than it looks on the camera. But yeah, so this is the solder paste on the pads. And this is totally within tolerance to get it on the pads. So it's not perfectly centered on the copper, but that's totally fine as long as it is not, I would tell you if it was off too much. All right. Twist. I had trouble parsing it, but it's Twisted Zitza. Thank you very much for the tier 1 subscription. I appreciate it. Yeah, it does. Yeah, totally. So, yeah, and we will. It's much sharper actually in here than under the microscope, and also over time this solder paste will slump because it does have some it is viscous a little bit, so it does sink a little bit. But yeah, I think I'm happy with the result. So let's go back to the next board. What I also use is for cleaning the stencils. I use this stuff. They're IPA pre-soaked, and you can buy them as a refill. So this is something I will show you on this. Depending on the board, sometimes I clean them after each application, but in production I do it every second one, and I don't clean the top side because that's not really necessary. What is necessary though is to clean the back side so that there is no solder paste slash flux that squeezes under the stencil. If it squeezes under the stencil, it becomes a problem. So I like just shoving it back into the holes, like just get out of the way, so that when I do the second board, it is not in the way and it's not starting to just creep out and create too much solder application. It really depends on the complexity of the board, how often I have to do it, but usually I try, when I have a panel, I do it every 2-3 stencil uses. I just wipe it on the back to get it out of the way. All right, so this is looking good. I think that's close enough. And now we do the dance with the solder paste like this to make a nice bead, like that. Put it down here and wipe. And also something I learned, if you can, do it once, one wipe, that's it. One decisive wipe. Do not wipe twice or 3 times or 4 times. You will squeeze stuff under the stencil. You will make a mess. Wow. And I destroyed it. Great. Well done, Peter. That was stupid. Okay. It's just a USB connector. It's just a USB connector. It's not a big deal. I think we're good. Yeah, and some of these. Yeah, I don't have to redo it, I think. It's not a big problem. I didn't make too much of a mess. You know what? Let's be careful. Let's be accurate. Let's redo it. Clean here. I dropped the stencil onto the board. Okay, so then you will see how I remove solder paste from a board. So the disadvantages of removing the solder paste, it will squeeze it into the vias, which is a little bit annoying. But the easiest way is just to take one of those IPA wipes, put the board under like this, and then wipe to the side. This will take off most of it in one big wipe. Quite cleanly. Let's see. How much do we have stuck here? Wow, I don't even have it in the vias here. I'm surprised. That cleaned very well. You have a little bit solder paste in here in these holes. But otherwise, it's pretty good. Well, that was successful clean. So let's do it again. So yeah. So there we go. So let's do that again. And there we go. And like this. Like that. Let's lift it. Yeah, also important to try to lift it so that you don't drop the stencil back on the board. Okay, and number 3. Oh yeah, I said I want to wipe it from the back, right? Come on. Sometimes I add like a little bit tab of like a blue tape so that I can pick it up easier by hand, but I didn't do it here. There we go. Number 3. I think we're good still. I still try to check it because it does over time creep. The Kapton tape that is holding the stencil in place can creep, or the board might be not milled exactly right and you need to move it. So it is like, it's good to check it, especially when you have a full panel. this happens way more. So you have to stay on your toes and keep checking it and maybe adjust the stencil position. And number 3. So that will be it for today. The rest I will do off stream. So if you didn't know, I announced this on Twitter. One of these boards will go to one of my Patreons. So I will assemble these, and if you are my Patreon, if you are supporting, you still can do that. I will choose a person to send it to next stream aka on Thursday. There will be another stream, and hopefully we will test them. And if they work out and you are my Patreon, you will have a chance to get one of the prototypes. And so just FYI. And I think I should expand that to those that are my subscribers on Twitch. I think that's not a bad idea to try to do that, because I appreciate that too. Exactly. Yeah, I think JLC PCB only makes the huge panels. Yeah, I don't know. I had issues with that. So yeah, there we go. So I can wipe the stencil off now. We should have an FAQ about what we are working on. I think that would be a good idea. So this is an FPGA development board. So you can use it to learn how to use FPGA. Nee, Alter. Servus Fake. Oh, that's awesome to see you here. That's so cool. Bytework is watching. Oh no. No, please don't. That's awesome. Nice to see you here. Yeah, good old friends. It's really nice to see them here. Ah, you did. That's awesome. And now I'm scared. Now I have Lampenfieber. That's great. Nice to see you all. All right. So now that the solder paste is done, let's move it here maybe. So I have the stencil, and I can just plop it back into the container. And there we go. Plonk. So I can clean the squeegees. Can close this so that it doesn't dry out more. So Bendim, what is it? What are the questions here? So essentially, what you can do with the iCEBreaker is like this is how it is really difficult to say what you can do with it, because you can do a lot of stuff on it. So essentially, if you have a microcontroller, like you have an Arduino board, you can do a lot of stuff. And if someone asks you, it's like, so what can you do with an Arduino? It's like anything your imagination can do with a microcontroller. The difference with the FPGA is it is like a one layer lower. So you can make it behave like a microcontroller because you configure just logic, essentially. If there's enough gates enough lookup tables or enough elements on the FPGA, you can do a lot of different digital logic stuff. So anything your digital logic imagination can bring to the table, you can do with it. So we have NES systems emulate, re-implemented on it. We have Game Boy re-implemented on it. We have some Blinky code. We have some driver code for LED strips. We have a graphics card for HDMI. We have audio synthesizers and la 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 la. Some of them are implemented on a softcore. Some of them are implemented just in gateware, which means just in logic. And then. So yeah, there's it's someone I should monitor the Discord if there's on Discord, if there are people that that I know and want to join in audio, thank you, Fake, for subscription. Now you will get notified, and now you will have to come. Oh, with Twitch Prime too. Thank you so much. I really appreciate it. That's really helpful. Yeah. Anyways, so come to our Discord, Fake. You will like it if you're into such things. Anyways. Babe Cafe, thank you for the Twitch Prime no, it's not. It's just a subscription. Thank you so much for the follow. I appreciate it. All right, so next thing is, after we did the stenciling, we have to assemble it. So here on the desktop, you will see I took the design, which is here. So this is the PCB design in KiCad of the board. So this is the FPGA here. This is USB connector. We have flash, which contains the bitstream configuration for the FPGA. Also, you can put, if you put an SoC like a RISC-V microcontroller SoC on there, which would be a softcore, you can run the code from the flash after the configuration was loaded. There is also a PSRAM chip on the back of the board, which eventually in the next revision of the board will migrate to the top of the board, because now we know, thanks to Greg Daville, that it is possible to squeeze things further. We have 2 voltage regulators for the 3.3 volt rail, as well as the 1.2 core voltage of the FPGA. We have a button, we have 2 LEDs, we have an RGB LED, and we have a bunch of GPIO that you can use. So yeah, this is that, and then using this plugin, which is Generate Interactive HTML Bomb. So this is a plugin, a Python plugin for KiCad. I generated, where is it? Where are you? Oh, I have to double click. This is like a newish thing. Okay, so I generated this, which shows yeah, it's best plugin ever. Best? Really? No. Yeah, I think you meant best. Yeah, it's really, really good plugin. It's really awesome. And we have all the parts in here, and we will just go one after another, and it will highlight the parts that we have to place. It's really, really good tool for hand assembly of boards. So we will start with the 100 nanofarad. So I actually had those marked for some reason, because I checked them yesterday that that I have them in stock and I have all the parts. So I did go through this here, and the cool thing is you can see statistics of the board in here, which is how many parts did you source, how many parts you placed. So I can go through here and just mark them, because I did that yesterday. For some reason, Firefox decided to forget my settings. Yeah, that's fine. Freudian spell, okay, the spelling, right? Or what is it? Freudian slip? Yeah, all right. No, I believe you. No, this is, I really like this plugin. So yeah, there you go. And so when I'm here under the microscope, you will see it in the left upper corner. There is the desktop, so you will see which part I'm assembling at the moment. So we will start with the 10 microfarad capacitors, 100 nanofarad. Sorry, what am I talking about? This is what happens when you try to stream. You do 3 things at once. Talk about it. Yeah, so the guys that make the AR overlay stuff, they did contact me several times. I need to reply to them. They retweet stuff also on Twitter. Yeah, good guys. I know the founder of theirs. I met him at Teardown, Crowd Supply Teardown, and he was at SuperCon too. Yeah, Inspect AR. Yeah, I want to use Inspect AR, but I have to contact them and ask them, so if you want me to use it on stream, how can I use the AR software as part of an OBS overlay? Because that's the only reason I would use it, to actually, so that on the in the stream you can see the overlay on the board where things are and which part I'm assembling. So that would be definitely nice. But I have their email. I have to get the reply to them finally. I feel bad that I didn't do that yet. Yeah, Mihir. Yes, that is him. He's a good guy. All right, so 100 nanofarads. So let's start with these. We will need 9 of them per board, and I like to pull at least some of them. In this case, I'm not counting them out because this is just too many to count them out. I'm too lazy. So I'm pulling them out onto the table here. So let me maybe refocus here. Will that help? Probably not visible very well. Maybe if we zoom in here, you will see what I'm doing. I'm not sure what makes more sense. Should I? I am not German, but I lived in Germany for a very long time. And I live in the US at the moment. So I am buying solder paste here in the US. But there are other people here in the chat. Just there's plenty of people from Germany or from Europe in general. They can tell you where to source solder paste. I think they are buying it from the usual suspects, like now I'm blanking on the name. Yeah, I'm blanking on the store names now. I'm sorry. But yeah, I'm sure someone, Farnell Mauser, something like that, yeah. This is where people are buying this stuff from, usually. Okay, so I actually want it closer. And I can do this. And I should rotate this because that's the orientation on my monitor. And we will start from top. So yeah. So this is number 1 here. 1. So now the tedious part starts, but it's less tedious than doing it with the soldering. It's much faster than doing it soldering by hand. So I see people come and say, it's like, oh, I assembled it by hand with a soldering iron. I have to see if I can get also the camera in focus. There we go. And let's see. There we go. Thank you. Or RS component, yeah, that's another one. Is that better? Is that focused enough? All right. And the last one here. So the PCBs are from Oshpark, if you were asking. So far no one was asking, but that's what it is. Both of these. I might be getting a little bit out of the view for some of the parts because the view port on the camera is smaller than the one I have in my eyes. The optical view is a little bit bigger than the camera one. And then we have these two on the bottom here. Left. And one to the right. Skip one. And then we go to the corner here. There's this one. So what I was hoping, what would be really cool, is get an etched glass plate into my microscope that shows me what the viewport is. That would be so cool, like basically like the crosshairs you have or the measuring diffractions. This would be nice. PCB manufacturer ever for prototypes? I'm not exactly sure I can parse that question. If I use a PCB manufacturer, I'm not sure. I'm not sure what the question is. All right, so we have these 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's just count them. That makes sure that I placed all of them. 1, 2, 3, 4, 5, 6. Wow! And it jumped. Where is it? Come on. Where did you go? Well, I think I lost you. I don't know where it went. It should be still on the PCB somewhere here. Because this... Ah, there we go. I found it. Exciting. And one more. Yeah, there are different techniques for that people follow. Placing bigger parts first and then placing the small parts. I find if I place the bigger parts first, they usually are in the way because they are taller, usually, most of them at least. And when I'm just hovering over the board and like try to place parts quickly, especially, I like to knock the bigger parts off because my tweezers, when I move them, when I translate them, they're, for the smaller parts, they're lower to the PCB and will cause issues because I will knock something off. That's why I prefer to put the smaller parts first. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, next. We ran out of parts here on the table, so let's get more parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, There we go. Yeah, these are all 402 parts, yes. So you can see the difference. This is an 0603 capacitor, and this is an 0402 capacitor. Godluzu, right? That's the name. Welcome to the stream. Thank you for the follow. I don't have the history now. It's like this too many windows open on my desktop. I need more monitors. I need like a Kate Temkin type of battle station. She has like what, 6 monitors? This she can like see everything. She's omnipresent. One, 2, 3. So you might see what I'm doing here. To stabilize my hand, I actually do take. Can I show it in these feet? Jesus, where is the camera? I do this. So I hold my finger on the tweezers and I rest my hands really firmly on the table. So both hands are resting, like wrists are resting on the table, and this way I am actually quite shaky. So especially after having a coffee. So this allows me to keep really fine motor control by just using both hands and like navigating over the boards. This becomes really an issue with big boards. This is another reason why I like small boards. Assembling prototypes is much easier because you don't have to like do something where your arms are up in the air and you can just really finely control what you're doing. And yeah, you see, for my tweezers are still moving. Also, you have to go for it. So this is another thing, another trick. Don't make. Yeah, see, my hand is shaking, but basically, you are creating a statistic prediction where it will land based on your shake. And yeah, it's a matter of a little bit of training there to basically anticipate your own shakiness. There we go. And then we have this guy. Then skip one. And then we have this. And I think there's one more on top there. Yep. So now we have the 100 nanofarad caps placed. So that's the sprinkles. The electrical engineer sprinkles are placed. So we can mark this as done. Next. One happy teddy bear. Thank you for a follow. I know who you are. We have a phone call scheduled for tomorrow. Yeah. You will see his stuff on the stream sooner or later. So that's that will be very exciting. Yeah. Okay. Next is 10 nano. 10 nanofarad. How many do we need? We need 4 of them. So let's just pull out a little bit of them onto the table. And they are going into 4 places. Oh, wonder. So let's start with the bottom board first. Really afraid of... It would be nicer to have like some kind of a frame, because my finger, look where it is. I'm touching it on the lower end of my finger, but it's like I'm still afraid that I will eventually smudge something with my hand if I'm not careful. Anyways, let's stop procrastinating. Let's place some more parts. The second one. Hello, Joe. Thank you for your follow. Welcome to the stream. There we go. I think that's the correct one, yes? Yes, it is. Good. The first board is always the most mysterious one. Wow, I dropped it too early. So sometimes the parts stick to the tweezers, most of the time, because they're small and you have some static or like stickiness to the magnetic stickiness to the tweezers. So you might sometimes want to demagnetize them. How I store the passives? I think I showed that. I have a box like this with flaps, and they have labels. So that's how it looks like. But I also have capacitor strips. Private what? Welcome to the stream. Thank you for the follow. Let me see. That's not the right window. That's Discord. Oh man. This is becoming really weird here. All right, so stream. Private Dijon. Welcome to the stream. Thank you for the follow. All right, so let's do the chat. What the hell? Come on, open. Oh, thank you. Thank you for joining in. I'm glad you were able to make it here. And I should move the mouse. This should. So one criticism for the HTML BOM, I wish it had a mode where it does not hover over. Highlight first pin. Is there showed footprint paths, fab layer, silkscreen values, dark mode? Yeah, you cannot just lock it to the line to keep it highlighted. You have to basically hover with your mouse over the part that you're placing. I find it slightly annoying. Okay, so that's a very common question. So some of you might know, others might not. I have a pick and place machine. So I could theoretically pick and place these boards, but essentially pick and place machine setup with everything set and done takes about a day. And even if the machine is already pre-programmed and I have to change it over for new parts, it can take. Can you null zero? What's going on? Should be easy enough to code in JavaScript. Yeah. Yes. So any type of microscope is definitely a good idea. The problem with the USB microscopes or like the camera ones is the lag. So it's still better than nothing, but it's not super great. I do recommend it's like go on Amscope, and for $300 you can get a microscope that will work for this kind of stuff. It won't have a camera attachment, but you get the optical stereo vision. That helps a lot. Having depth, it's like, of course, if you don't have depth perception anyways because you only see out of one eye or something, that doesn't matter. But for those that can see stereo, a stereo microscope is definitely makes things easier, and you can control things better. The depth control is somewhat important to make things easier. It is possible without it, of course. But yeah, I would recommend if you can, if you are able to, get a stereo microscope. They're not. I think if you're doing it as a hobby a little bit more than just once in a decade, get a stereo microscope. So you are one of those. I didn't even think about that. Yeah, we had those conversations. We have them on the Discord on a regular basis, and yeah. I'm being distracted by the chat, but it's good. Got some from a local shop here. Yeah, it's a lag. Yeah, it's like having something is definitely an improvement. Like having some magnification is definitely worth it. So that's a good recommendation here. Oh, I already placed this one. Okay, now I have to focus on these because I will start making mistakes. So let's finish one part and then I can look at the chat. So let's make that a rule. I place one part on all its footprints, one type of part, and then we can look at the chat and see what's going on. Unless someone wants to go in audio and wants to ask me questions in my earpiece. So yeah, there we go. That's correct. And the lower one is on the bottom here. There we go. 3 more, and then we can move on to the next part. One, 2, 3, one more. Missing one part. That was 2, and one more. 10 nanofarad. There we go. And 3. Yes. Good. All right. So that's done. All right. So what did I miss? Oh yeah, you just practice with big parts. 0805. 1206 is really big though. But 0805 is totally fine. You can do it by hand and with no magnification for sure. And yeah, I do recommend trying the stencil and reflow solution if you can. Get either a heat gun or get a hot plate, or even better, of course, a reflow oven. The Chinese reflow ovens just need a little bit of modification. If you have a hackerspace locally, make it a group project. Get one of those Chinese reflow ovens and modify it and make it into a reflow oven that you can use as a group. Yeah, I still have this pending project where I have to modify a reflow oven, and on my blog I have all the steps described, but I don't have photos or a video for it. So there will be a video and there will be photos for all the modifications that I did to my ovens, so that you can reproduce them a little bit easier. So that's a pending project too. So how many do we need? We need 3 per board, 1 microfarad. 1, 2, 3, 1, 2, 3, 1, 2, 3. Wow, too many. The rest goes back. There. So yeah, you see I'm starting to count them, but I need a sip of water. There we go. Hydrate, hydrate. There we go. 1. Oh, we should start at the bottom, huh? Shouldn't we? 1. I see there's fibers in here from cleaning the board. I should remove this. Oh, thank you very much for the follows. That was quick. Ralphin Ninja, thank you very much for the follow. I appreciate it. So my Twitch monitor here is like saying there is a 35 minutes. Well, I think our stream will go a little bit long today. I have the feeling, because we started late. And so yeah, just brace yourself. It might be longer today. Or I have to brace myself, to be honest. Come on. There we go. Let's go back. Wow. Come on. So, chunky O402s. It's funny how you see that the difference in manufacturing between values of certain chips. So some of them are like, you see the capacitance is bigger because they feel like they're thicker in like design. They are like not as the smaller values usually are in a slightly smaller package because they have tolerances. But yeah, it's funny how you see the difference there. Oh, great. Now it flew. Don't squeeze the tweezers so hard. Zemia Gulta, thank you for the follow. Welcome to the stream. And I lost the part. Anyways, whatever. It's not that big of a problem. Just don't squeeze them so hard, Peter. I will find it like tomorrow, somewhere on my table. Jace Hazoid, thank you for the follow. Welcome to the stream. There we go. 2. Oh, I'm out of view. Sorry about that. Yeah, but I warned you. This will happen because my view is bigger. The microscope. Oh, come on. Don't be a jerk. There we go. So 3. Yeah, we will have to pull out one more because I lost one. It flew away. Decided to make a journey, explore the table, the vasts of the table. I hope it will come with some good stories back. There we go, and one more. 1 microfarad. On the lower one. And here we go. 1 microfarad. Okay, good. Next. 4.7 0603. And we need 4 of them. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Yes, very good. Okay, so they go all here in this section. 1, 2, 3, 4. So yeah, you see the difference in size, the 0603 versus 0402. Let's try to get that in view this time. 0603, 1, 2, 'It's surprising, actually. I was slightly afraid of doing the 0201s with the same technique. So even smaller than these 0402s. Yeah, stop flailing. But yeah, It actually is not that bad. I thought it would be much harder to do O201s. It was actually pretty easy. It's just slightly more fiddly because they're smaller. But yeah, you just place them on the pads and you're done. I was assembling the power board of, what was it? This was the power board to the Novena laptop. Someone was building a Novena laptop and came to me and said, can you help me assemble the power board? So I did that. And fun fact, Bunny just copy-pasted a microcontroller layout from a different section of the laptop onto that power board. And that was the only section that was using O201 capacitors. Everything else was O402. Because I asked him, it's like, hey, Bunny, like, what the hell was going on that board? Because the microcontroller was the only one that was using O201 100 nanofarad capacitors as the coupling capacitors, and everything else was using O402. Why mix the parts? And he was like, oh, yeah, I just copied the layout from a different section of the laptop, 1-to-1, and just didn't bother to change them. So it's like, that makes sense. All right, so now we have 10 micro. We have one 10 microfarad capacitor that we need to place. And this is here. So we need 3 of them. 1, 2, 3. For some reason there's like an O402 that mixed in here for some reason. That's weird. Is that a diode? Yeah, that's the problem with the open things. It's like it's possible to mix parts. It did happen once to me. Yeah, that Bunny. The Bunny and Zobs that work together. They do awesome stuff. They do, what is it currently we're working? So they are working on the Be Trusted platform now, which is really cool. Watch his Bunny's presentation about Be Trusted. It's very interesting. It really talks about the expectations we have for open source hardware versus open source crypto and whatnot. It's very interesting. They're working on really cool stuff together with Sean. All right, 10 micro, so that's placed. Then we are going to resistors, 10 kilo ohm. Where is it? There is 10 kilo. So how many do we need? We need 4 per board. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3. One more. And 4. Yay! There we go. Very good. Yeah, Andrew Hung. Yeah, he's a good guy. I meet him only like once, maybe twice a year at either the Congress, CCC Congress, or he came to Crowd Supply Teardown 2 years ago. Sean is traveling more. He comes to more events. Sean Cross, Zobs. They work together. Yeah, I really enjoy hanging out with them. They're good people. Yeah, there we go. 10 kilo. There we go. 1. 2 is on the bottom. Should we go on the bottom? Yeah, we should go this way. 10 kilo. And this one is also the pull-up. It might be, yeah, it would be useful to have essentially, so that would be a really cool feature for Twitch, so to have a dual screen setup so that you can see the parts and the schematic of what I'm assembling on a second feed of video and me seeing me assemble this stuff. I think that would be the ideal setup to have for this kind of video streams, to actually see how the design, because in my head I see the design, I know what the parts do. It's like, oh, this is the pull-up for this and that. Or not always, sometimes I also, it's like, what is that pull-up for again? So I know that this pull-up, so this is actually an RC network, this one, the first one, that, oh, I forgot one part on the bottom there. I should focus more. 1, 2, no, I did. 1, 2, 1, 2, 3, 4. There it is. It's fine. Okay, so that was good. Yeah, so this is an RC network that delays the power up of the 3.3 volt rail so that it is after the 1.2 volt rail. The reason for that is you want the FPGA core voltage to come up before the 3.3 voltage of the I/O of the I/O banks. At least that's a recommended thing. I don't think anything will actually really break on this part because it's pretty robust, but it's a good practice, you know, to try to adhere to the rules. And this pull up here is for the oscillator. So this actually is the enable for the oscillator. In theory, I could just tie it to 3.3 volts. I think it's a pull up, not 100% sure. But yeah, I could just have it pulled up, I think, but why is it connected so weird? I'm now confused. What's going on here? Oh, this is 3.3 volts. I don't think it is for that. I think it's something else. I think it's a different pull-up. Oh no, it is the pull-up. So it is the pull-up for this enable pin of the oscillator in here. Yeah, that's right. Yeah, YouTube does support multiple camera views. That's true. I am pretty sure they have that capability on Twitch too. They just don't offer it to everyone. I think you have to be like partner, because I've seen some of the sport transmissions, like esports transmissions going with multiple streams that you could switch between. So I'm pretty sure they have that capability too, but they might not be offering it to everyone. Okay, anything else? Do I have them all? Oh, this one is missing, right. Yeah, I had one more left here. That was weird. There we go. Placed, good. Yes, they are ARM. These are ARM tweezers. I love the ARM tweezers. These are E7SA. I love the crooked ARM tweezers, these guys. Yeah, you can pry them out of my dead cold hands. They're amazing. I love those tweezers. They are not cheap, but they are worth every single penny. They feel so nice, and it's, yeah, I love those tweezers. It's nice to have cheap tweezers, cheap, crappy ones around for butchery stuff, but yeah, these are nice. Okay, let's mark it. I need to take a very short break and be right back, and then we will continue. Yeah, I know this stream will go for a little bit longer today because we still have a bunch of parts to place. Sorry about that, but yeah, I'll be right back. All right, sorry, I'm back. All right, next part. 22 ohm. So the 22 ohm are the inline resistors for USB. That's pretty clear. You need two of them. So in this case, as I described it earlier, this FPGA is driving USB itself. So you get full speed USB implemented in the gateway of the FPGA. So it does not have push heading. Thank you for following. Welcome to the stream. So yeah, this is what we have here. The third footprint on the bottom, this is the pull-up resistor for pulling up the USB line to indicate that you want to that you are present or you want to disconnect. So that's that. And this is a 1.5 kilo ohm resistor, and these here are the 22 ohm inline resistors. Essentially inline termination, I would say. There we go. 22. And last one. Okay. Wow. Come on. No. This is funny when you get a pick and place machine placed board and then you have flipped around parts. You are like, how did that happen? Because usually the machine would reject something that is not properly aligned on the nozzle. It's like, how did this part get flipped? Yeah. All right. And then 330 ohm. These are the inline resistors for the two LEDs we have here. So we have red and green LEDs on the board. And we use 330 ohm resistors in line with them. 2, 3. One. And 2. So as a fun fact, this is the footprint of the RGB LED down here, which is really tiny. And the RGB LED doesn't have inline resistors because this FPGA has 3 magical pins that have current control. They are dedicated, they are meant for this kind of application to connect LEDs to it. So you can set drive current on those pins and control the LEDs like that. So you don't need inline resistors. The other two, the red and green LEDs, are connected to normal GPIO, which means we need the inline resistors to limit the current. There we go. Okay. So these are now placed too. What is next? We have 1 mega ohm resistors. These just connect the USB shield, so the casing of the USB cable to ground of the board, just to have a connection. There are many ways people do it. Some people just use a ferrite, some people use connect it directly to ground. I've seen like a zillion different ways of connecting the USB cable ground to the PCB of your device. I decided to go with the 1 mega ohm resistor. And there you go. Didn't have to even look where it went. Okay, the 1.5 kilo ohm pull-up resistor, as we described before, for the USB detection. 1, 2, 3. Just 3 of them. They're current controlled. So the cool thing about this FPGA is it has PWM control. So the on-off is current controlled, but then additionally to that, it has some hard IP for PWM control. I think, as far as I'm not mistaken. I didn't look too deeply into this peripheral or these blocks, but yeah, I think they are individually PWM controllable with hard IP. And to explain what that means, hard IP in an FPGA is any logic that is not requiring to be implemented in your HDL in the fabric of the FPGA in general. So there is a hard IP SPI controller in this FPGA, for example, which is not very fast, but it's there. And it's used to load the bit stream into the FPGA, but you can also use it yourself later. Then there is a hard IP block for warm boot, which allows you to restart the FPGA and then reload the bit stream from a different address offset. This is what we are using for the bootloader, for example, to have a different configuration of the FPGA first when you power it on, and then after you program it, it can restart into a different bit stream that you can load as a user. So that's how that looks like. All right, so that's the pull-up. Next, 100 ohm resistor. I don't remember what that. Oh, that is some like smoothing resistor. It's for one of the power rails. I feel it should be actually a ferrite instead of a 100 ohm resistor. It's like, I don't know why the reference design from Lattice uses a 100 ohm resistor here. Maybe Sylvain knows why, but I would rather put an ferrite in there, to be honest, to have a smoother filter for the PLL supply. Yes, that's correct. And so I would rather put some filter in there instead of just limiting the current, I guess. But yeah, this is what they do here. I just copied it from their reference design, which is arguably has its problems. We had to fix a few things from the reference design that we learned over the time. Yeah, okay, so it uses so little current for the PLL that it doesn't matter that it is a resistor instead of a ferrite. It's just an intuitive, like a gut feeling thing where it's like, yeah, is that the right thing to do here? Ah, okay. I could use a much higher resistance. That's a cool idea. I actually should reduce the bomb line count. Bomb line count is a pain in the butt. I don't like additional bomb lines, especially for just one part if you can get rid of it. Okay, 2.2 kilo ohm resistor. This one is a pull-up for the C-done circuit, which is super weird. So the C-done is being pulled, I think, high by the FPGA when the chip thinks it is configured correctly, but we also use it to indicate it with an LED. So I've seen on your board you are still using the green LED. Huh, interesting. Thanks, Jared. So that's an interesting take. Oh, you added a transistor. Okay, so two things. So first of all, this is the part we will be placing. This is the resistor, which is a pull-up for C-done line. C-done indicates if the chip is configured, but also it doesn't start unless the line goes high. So the FPGA sets the line, but also reads the line, so it has to make sure that it is high voltage enough. So it's good to put a blue LED, for example, in there, which has a high dropout voltage, so that it is above the VIH of the chip, so it sees that it is actually high. I've seen so we had a problem with that, and Sylvain uses a green LED because he added a transistor in there so that it is not a problem. Second thing, regarding the resistor, Jared is saying, which is a good point, that the resistor is less frequency dependent. So if you have a PLL which introduces a ripple onto this line, it is better to use a resistor instead of an inductor, because an inductor could interact with the PLL operation, which is interesting. I didn't think about that. So yeah, so I guess I learned something today. Yeah, let's not have burnt chips. That's a good idea for sure. So 2K2. 1, 2, 3. Just need 3 of them. One. Started in the middle, I know. One. Come on. 2. And 3. Okay. And next one is the 10K array. Let's see. I think I did pull 10K arrays out. I didn't have them in my box before. 2. Come on, one more. So this is an array of resistors. There are 4 resistors in one package. So this is this guy here above. This decreases the amount of placements you have on the PCB. Instead of the machine having to place 4 parts, you place just 1, which is nice, especially when you have more of the same. This basically just moved over from my design of the big iCEBreaker, where I have more of arrays like this. I have 33 ohm inline resistance for the it's like inline termination for all the GPIO that go to the outside. I have 2 of these 10K ohm arrays for different pull-up resistor uses. Wow, this is terrible. Okay, I will probably have to rework this one afterwards. Well, we'll see. And then I have also 330 ohm resistors to consolidate the LED inline resistance stuff. So that's done. Now let's place a blue LED. Let's see how many blues I have in here. Should have pulled them out, I think, from the machine. 1, 2, and 3. 3 blue LEDs. So the solution here, so I'm not sure you will see this. Oh yeah, you do. See where the die is on the side? So see inside here? So I actually rely on where the die is. Where the die is like glued down to the substrate, that's always, let me not make a mistake here. That's always pointing to the ground pin. So this is where I put it, is connected to ground. I hope I didn't make a mistake. So yeah, this is how I check the polarity usually. is by looking at the die and where it is in the package, instead of trying to turn it around, which is also possible. You will see on the back there's an arrow. The third solution is to take a small mirror, like a glass mirror, put it on your table, then you can put down the part and you will see in the reflection, because there's glass between the reflective surface and your chip, it will reflect and you can see from under the chip with the marking on the back, which makes it fairly easy. I don't do that. I just try to see in the package where the die is, and the die is usually has the bond wires going to plus. I hope I didn't flip it in my head during the stream. It's like but I think this is correct. Acrobatic, thank you for the follow. Welcome to the stream. There we go. 2 and 3. And so far, all the diodes that I played with are configured like this. They have the die bonded to the ground pad, are like sitting glued onto the ground pad. Okay, so that was blue. Now let's do green. Green, green, green. One. Two. I'm not 100% sure I have the bright or the little bit dimmer ones of these. And I think there might be a mix of LEDs in this section. So how do the backs look like? Let me just check it really quick. They look the same. 2. I could test them with the multimeter too if I wanted, but it's usually not necessary. Wow! Where did it fly? Come on. Don't fly. Stay here. This one is really not wanting to incorporate. Okay. Oh, this is a different one. Let's get all 3 the same at least. Is this one the same? Yep, so these are the same. But yeah, we should do some, still always do some polarity, God's prayers, whatever. All right, so the same thing. And this one is much harder to see because it's an opaque, not opaque. It's diffused plastic on the top, but I still see a darker dot on the side. You still see it here. It's a darker dot on the right. So what we need to do is place it this way. That way, there we go. And same thing here, ground. And third one. Oh, that was lucky that they were all oriented in the same direction. Fun, fun. Okay, now red. Let's see if I can pull them out. Should also check that they are at least the same make. Yep. Oh, this is different. Okay. It's not that it really matters, to be honest, because I don't have the same part. I only have it one per board. Wow, this is a lot of different parts I have here. Oh, I have 3 of this. Okay. Let's put the rest back. Damn, it's warm today. It's like it's cloudy outside, but it's still very warm outside. It's like it's warming up in my room quite significantly. Okay. 1. They are fairly easy to rework too. It's not that I'm too concerned with that. If I need to take them down and put them back in and rotate, it's just annoying at best. There we go. And done. Okay, next. Green and red, we did these. Now we can place the... Oh, tri-LED. That will be fun because I'm not sure how the polarity works on these. So I got some from AliExpress. No, from LCSC. So let's see. We need these. This is a bunch of stuff that we will need. So let's pull it all out. This is the PS RAM. No need that at the moment. These are buttons. This is the LED. Red, green, blue. Damn, these are tiny. This is awesome. Look at these buggers. Holy schmoly. These are tiny. I might go back to some bigger parts for these. These are super small. 1, 2. Need 3 of them. There we go. Oh, it's hilarious. Yeah, so they have the marker. How does the marker reflect anything? Oh man. I think I need to take a look at the datasheet. Because I have to figure out where the marker should point on the board. Should I have it to the left, to the right, or something? I know that the pin 1 is in the right upper corner. Ah, Paul, welcome to the stream. Nice to see you again. Cathode should be chunky. Cathode should be chunky. It's not very chunky. They all look the same. I just have this 1 pin marker, and I don't know where that pin marker is meant to go. Oh, do you not see that? You don't see that. It's here. So there you go. So this is how this looks. And now I have to figure out which way to point this pointer here. So let's see. So this is the, let's copy this number. What? Oh, it's right there. DG part LCSC Foshan. Zeman 1942, thank you for the follow. Welcome to the stream. I could probe it. Yes, I could probe it. I think the easiest thing, though, is just to look at the data sheet and see where the marker is supposed to be. Right, there you go. So pin 1 is to the left of the marker, so it means the dash should point up on my board, correct? So if the dash here should point to the so pin 1 is this one, correct? No, it's wrong. Pin 1 is the top one. Correct. Yeah. So it's this one. Is it from the top or the bottom? That's the question of the view. Is it a top view or is it a bottom view? Jerks. I think it's a bottom view. Yeah. God damn it. Okay, let's try this. Let's see what my multimeter says. So, let's assume that this is bottom view. And basically, that should be then ground. Yep, that's it. And it's lighting up. I see it light up. Yep, I see red. Okay, cool. So it is the bottom view. It would have been nice if they said if it is bottom view or not. Wouldn't it? Data sheets. So if this is 1, then it means it goes here, so the dash goes up. Man, I should rotate it so that it doesn't. Oh, man. Okay. Yep. So let's see. There are 3 dots, and the red die is on the right. I see a slight shimmer of red on the right side. So, considering that the dash is now on top, dash on top, dash on top. No, that's wrong, right? So if this is rotated, so this is pin 1, yes, dash on top. Okay. There we go. Let's see if that works. If it doesn't work, we will rework it, obviously. So let's place these. So the red one is on the right. Yep. There we go. Placed. And oh, that's, I just picked it up like that, it happened. And let's sack, yeah, it looks good. Oh, come on. Oh. There we go. Placed. Sweet. Awesome. Red. placed. All right. Did I pre-bake them before assembling? No. I heard horror stories about especially WS2812 LEDs, that they were just popping as well. It's like, I think some people had FPGA issues with some substrates. So far, I didn't have issues with popcorning. But Ralph the Ninja, welcome to the stream. Hello, how are you doing? Yeah, so I didn't have issues with it, and it's like I didn't pre-bake that. I might do that in the future. It is, yeah, it wasn't an issue so far. All right, the iCE40. Let's place the iCE40. I prepared those, so I can place these. So the pin 1 is here. And placed. There we go. Nice. That was the middle one. Wow. It's again started in the middle of it. Of the lot. And pop. Let's move it to place. To position. And do that. Good. And one more. Oh yeah, all the passives are placed. I didn't even realize how fast we went through them, actually. Oh, fast. We are beyond. It's like 20 minutes in. Well, now it is 2 hours since we actually started doing anything useful. And me being done with ranting about USB-C. Rewind to the beginning after the stream if you want to hear me rant about USB-C. That will not be in the archive. So, be quick. I mean, it will be in the VOD of Twitch, but I will not be making an archive of it. It's like it's water under the bridge or something. Yeah. Yeah, Ralph, that's fine. Yeah, I'm aware that people come in and out and come later. That's fine. I will try to answer all the questions if I can. I appreciate you apologizing that you're late. That's fine. It's yeah, so it is a reflow oven technique. So basically, I put solder paste down with a stencil, and then place the parts and then reflow it in the oven. I hope I get the orientation right. Yeah, the pin 1 is up there. It's marked. So this is the flash chip. Nice big flash chip that we can, it's connected over QSPI. Actually, it's DDR QSPI to the iCE40 FPGA, so we can read it out quickly, at least in the world of flash, which is slow as molasses, but it's still quite fast considering. Yeah, and the chips are being programmed later. Don't have them pre-programmed. Okay, 3.3 volt voltage regulators. Let's get these. 1, 2, 3. 3.3 voltage regulators. That will be number 1. Then number 2. So these will be actually replaced with DFN parts in the next revision of the board, because they have better heat dissipation, for once. For two, they will save me some more space on the board to make the layout a little bit cleaner when I put the SPRAM chip on the top of the board. Zgogs, welcome to the stream. Thank you for the follow. Okay, so that's done. Now we put the 1.2 volt regulator. This is an FPGA development board, so it's not an Arduino per se. Root, thank you for your follow. Welcome to the stream. 2 and 3. This is 1.2 volt voltage regulators for the core voltage. There we go. Biased, I think that's the name. Thank you for the follow. Welcome to the stream. Seems to be a bunch of people after 2 come to Twitch, which is nice. Thank you. Thank you. I'm glad you enjoy it. Yeah, just assembling some FPGA development boards for people to play with. All right, there you go. Okie dokes. So, next we need the USB diodes. So these are Schottky, I think, or Zener, whatever. It's an area of diodes to protect the USB lines from Zappedoodoo. ESD protection, aka ESD protection. The Zappedoodoo is the technical term, obviously. And there we go, 1. And 2, let's see, do we have this? Yes, good. All right, 2 and 3. Third one. And 3. Whoa, come on. All right, so that's the diode. Now we need the oscillators. Okay, so that's the oscillator. Let's hope it will work. So this is also a new part because I wanted to replace the less common footprint, which was an SOT, SOT 23-5, which is like the voltage regulators. And this is a more common, oh come on, SMD package. So I could get it from LCSC. So these 3 guys. So these are oscillators. These are not crystals. So they oscillate on their own. You don't need to drive them. Essentially, it's these. Okay. So where was pin 1 here? On the corner here. I think that's what it is. There we go. Nice package. There we go. Let me check if that is adhering to the, let's see, pin, I think it is correct. Yeah, so it has the marked pad with the chamfer. And it has the dot. Good. The dot is consistent with the chamfer, so that's good. 12 megahertz. Ba-chunk. And the last 12 megahertz oscillator. You see how the chips like poke around? Come on, guys. Stay on your pads. Stay in line. It doesn't really matter, they will. Yes, mine keeps the optical path on both eyes because I learned it the hard way. You have to buy a simulfocal microscope, not a trinocular microscope. A trinocular microscope, you will sacrifice one eye for the camera. If you want to use the camera, one eye doesn't work. If you want to use both eyes, the camera doesn't work. There's only a lever on the side. You can see that they are simulfocal mostly by also this variable zoom on the side. They cost a little bit more, but yeah, this is definitely the solution here. It's get a simulfocal microscope. Then it will keep all three paths enabled at the same time. Yeah, this board is actually double-sided, but we will solder the chip on the back by hand because I'm too lazy to reflow both sides. Or it doesn't make sense for one part. Let's say it this way. It's like I'm not too lazy. It would be much more tedious doing it otherwise if there were more parts on the back. But there's only the PSRAM, which is an optional part. It's actually it's meant to be populated by the user, but all the prototypes will get them populated because I have the chips. And I will change the system, so the layout of the board, so the PSRAM chip will be also on top of the board. And so in the future, when we go to production with these boards and make them available in the store, they will all come with PSRAM pre-installed. So that's the plan here. Okay, so we have the tact switches. That's the tact switch. That's a user button. It's also used to force the bootloader to stay enabled, but don't think we will have, yeah, we will test them on the next stream on Thursday. Now it's pretty clear considering what the time it is. It might power them on a little bit. We will see. Stay tuned. Decisions to be made. All right, 3 tact switches. And the last part is the USB connector. So I have them prepared here too. We should rotate this, make it easier. Rotate, rotate, rotate. Okay, so there we go. The PSRAM chips come in multiple sizes, but I will be using the biggest one I can get, essentially. That's the plan, at least. What do I have here? I think I posted them on Twitter. 64 megabit. They're smaller ones than these. I don't think there are bigger ones. I have not seen a bigger one, at least not on LCSC. There we go. USB connector placed. Number 1. Number 2. Let's do this. Number 1. There we go. Number 2. And number 3. And okay, that one was a little bit crooked. That's fine. Not a big problem. Okie dokes. So that's placed. So let's see. Now I can bring it to the oven. Now that is everything placed. Let's close this. Let's make sure everything is closed here. All right. So before I bring it to the oven, let's try to show you here on the desk really quick. Let's go to the desktop. All right. So that's these are the boards. Now I can go and put it in the oven on the front porch. So I will be back in a minute. I will leave you with maybe the view of these. These are the unpopulated boards, iCEBreakers. Yeah. So this is a previous generation board. You can look at that. And for comparison, here is Paul's Teensy. That's a Teensy here. So you can see that how the Teensy compares. Ooh. Teensy. And there is a tiny FPGA here. And so on. And the FOMU. That's the FOMU. Yeah, there you go. So I'll be right back. I will mute myself here for a minute. Okay, I'm back. Yeah, let's set a timer for 10 minutes. That's how long the reflow usually takes. It will be probably longer than that, or shorter than that, but we can just set a timer for, let's do 8 minutes. Might be a little bit toasty when I pull them out like this, but yeah, this way I will be there earlier than later. But yeah, we have a few minutes for us here. Yeah, so you missed my USB-C rant. Yeah, so the USB-C part, it's like this will be posted as a VOD, so video on demand, after the stream is over. Like Twitch posts it into video section. Yeah. Yeah, I don't know. The underlying thing is like eventually I will be using USB-C. I don't see a rush. No. And yeah, I find it funny that there are some people that are so enamored with the USB-C that they go out of their way to, it's like, to put a thumb on the scale. It's like, I switched everything to USB-C, so why can't I have yours? Anyways, yeah. Anyways, it's you can listen to it later. Yeah. Otherwise, I'm just waiting for this to reflow, and we should be able to test it. What we could do is actually see if I have this programmer. So I made this, which is basically an FTDI chip with an adapter, and this should be able to program it really quickly, so we can at least get some blinky on the board really quick. So to do that, let's see if I have an example here that will work for us. So you see the scrolling indicator of typing. This is a cool new tool that Spima, who is here in the chat, wrote. This is what also you can see my clicks, like as hovers on my mouse. Left click, right click, middle click, scroll up, scroll down. It's really cool. And then also I control click. It shows what it is. It's so cool. I really like that visualizer. It is, what is the name of it? Let me see really quick. It is called Tray Keys, and you can find it on GitHub. And it is a Qt application, so you can definitely get that. He's still working on some additions. It's like, because dangerous when typing passwords. Yes, very dangerous. I hope I will not type a password while I'm on here. Okay, so we should. I'm using it mostly for KiCad. When we do KiCad design, it is useful to see what buttons I'm pressing when I'm indicating things. So it is nice to have a preview of the buttons I'm pressing for applications, so people can see what the weird where is it? There we go. Okay. Let's see. Hooster9, thank you for your follow. Welcome to the stream. So we have iCEBreaker examples. That should be good enough, and then we should just do the blink count shift. That should work for the board too. I'm not sure. Does it require anything else? Yeah. So Spima, if you are watching it, I think this scrolling. So he added that recently. In properties, I can set this minimum speed, and it has an adaptive speed. But I think the adaptive speed, the maximum of it should be even further, like even faster than the maximum it currently has for the scrolling. Like especially when the buffer really gets full by me typing a lot, it might be overwhelmed still. But yeah. Anyways, let's clean this and then make. Should export Yosys. SFT will be good. Make. So that should synthesize it, the example. And then make prog is one way of doing it. I type fast. Yeah, thanks. Yeah, I'm sorry. So make prog is one. There's no FTDI device, obviously. So if we take a USB cable, let me get a USB cable. And let's program a iCEBreaker with this example. They should be pin compatible per se. I think the green and red LEDs. Yeah, so at least I should be able to get one. So if I have the iCEBreaker here and then do make prog, this would program it. Reading, and so it is blinking. And the problem is, I think I don't have enough buttons on this to actuate all of them. So let's change the bit stream. Or maybe PWM fade. Yeah. There is also a PDM fade gamma. Fade gamma. Let's program this. Where should I put this? Ooh, there. Yeah, so this one is actually exercising the two. Let's put it on the table in some place and move the camera. Come on, USB cable. Be compliant. Let's focus it. So they should be fading. I'm not sure this is very well visible. Will it still focus? Yeah, so the red and then the green. So this is what we are looking for on the iCEBreaker bitsy. And if I program it, it should do the same thing. So I think this example is better because it will exercise the... We don't have a button to exercise, but at least we see that it will configure itself and load some design in there. So that's I think good. So let's do that. And we can just use this programmer instead. Cool. So someone, I think, followed. So let's say hello to them. Boom leg shot. Welcome to the stream. Oh, yeah, got it. That was very loud. Okay, yeah, so welcome to the stream. Thank you for your follow. All right, so let's pick it up. And where's that window? There we go. So that's the chat. All right, be right back. I will just pick it up. I'm back. Let's see, someone followed again. BP Merkel. Welcome to the stream. Thank you for your follow. Okay, so there we go. Let's look under the microscope how they came out. That's nice. I don't see obvious shorts or anything. Let me zoom out for you a little bit. Let's see. Yeah, there we go. That looks good. That's the FPGA. Even the RGB LED. That's looking pretty good. That's looking good, okay. button is there, so that's one. Number two. Number two. It's a little bit shifted, I don't know why. It still looks okay, I guess. The QFN looks great. These look good. And these look good. So this is where the PSRAM goes. I will not solder it on immediately. I will just, let's first do the quick test. And on the next stream, yeah, let's do this one. On the next stream, we can do proper testing with some additional software like MicroPython and whatnot. So tomorrow I will have some time to prepare for that and get Sylvain's bootloader running and whatnot. But for now, let's so yeah, I need a second USB cable because this needs also power. Let's see, where do I have another USB cable? There we go. I think I have one. There we go. So that's the second USB cable. So let's see if it is getting hot. And darkness, good. I don't have a power indication LED. It's not getting hot, so that's a good sign. I still need the ground pin here. First, I'm missing that from my previous setup. Come on, where can I find a loose pin? Let's do this. Let's do this. Let's see if that works. This is how this plugs in. This is too long. So that should work. All right. Let's see. Let's run make prog. Programming. Reading. Difference in flash file. So it tried to program, but it failed. Because my connection is wonky. Reading. Verify OK. Sweet. It works. Configured and it's fading. Nice. That is very cool. Yeah, it works. Very good. So let's try the other two. Okay, that's number one. Let's go. Yeah. Awesome. So let's do the other two. Programming running. Programming. Reading. Verify OK. Sweet. It works. Nice. Number two works. 2 of 3 for now. Now, come on. Where am I? Here. All right. Oop, there. 6-star, thank you for your follow. Welcome to the stream. Programming. Reading. Sweet. Works. 3 of 3. Very nice. Okay. So we have working boards. That's awesome. That's good news. Yeah, so that means the oscillator actually is working and we are getting stuff to work. And so now the next thing will be to get the bootloader running on this, get MicroPython running on this. I will solder the PSRAM on the back. But we are like almost an hour over the time limit usually. I try to keep it to 2 hours. And yeah, so that's very successful. Yeah, cool. Thank you very much, everyone, for joining. We have very cool new toy to play with. Thank you for being here for this exciting project. There is definitely more to come. And as I said on Twitter, and I said here, because I will be making these prototypes, my idea was I would like to thank those people that support making these streams in some small way. So one of the prototypes will, on the next stream, I will give out to one of my Patreons or the people that are subscribed to this channel. It's like with the paid tiers of the subscription on Twitch. I don't know what the exact technical term is, but yeah, the subscriptions. So until Tuesday, so the day after tomorrow, you still can just, if you want to support this and you want to have a chance to get one of those, let me know. Just keep in mind that these are prototypes. We might change pinout, we might change things, we might change stuff. So if you're still a supporter and you don't want one, you are happy to say it's like, no, pass it on to someone who might have a better use for it. That's fine. I still really appreciate all the support from people because making these streams takes a lot of time and a lot of effort, but I really enjoy having the group development here and sharing my what I do and what I'm passionate about. Hopefully you are learning something from this. So since last stream, we actually got quite a lot of additional Patreon supporters, which is really awesome. Thank you so much, everyone. Yeah, and yeah, next time we will be testing, hopefully, maybe even MicroPython on this, which would be really cool. But at least we will get a bootloader on this and try a bunch of different things during the next stream on these boards. So I will show you what we can do. And from there, we will take it to the next revision of the board and do the next spin where we make a lot of tweaks. We will compress the board, move stuff around, and improve it beyond what it is now. But this is already promising and shows that it is a working board and can be used for FPGA development as is, because you can just flash it directly over SPI. I hope the bootloader will work too. I expect it to. Anyway, so again, thank you everyone who is making this possible, and I wanted to give the shout outs to the people that put some money in the bucket to pay for the hosting and stuff. So Jamin, Brennan Ashton, Drew Fustini, Edward Borden, Go Jimmy Pie, Jeff Wong, Jordi Parky Rodriguez, Kelly, Miha Banovets, Sid Price, Tom Caddy. Thank you all for supporting these streams and making this possible. It's really cool. Yeah. Anyways, so as always, if you have been, thank you for watching. Bye.